Now, let's see how we can do lighting in OpenGL. And I'm going to use this program right here, which we're actually scrapping the program that we've been building up for the last 3 lessons and starting with a new one. So here it is. We have our init rendering function right here with a couple of new functions, or rather a couple of new calls. We have GL enable GL lighting to turn on lighting. And by the way, you can call GL disable GL lighting if you want to turn it off. It's the same way with every one of these GL enables. Just call GL disable if you want to turn it off. Now we're going to have 2 lighting sources, so we're going to enable these 2 lighting sources, number 0 and number 1. Actually, you can have a bunch of different lighting sources. You can have at least 8 in your scene. And then we're going to call GL enable GL normalize, which I'll get back to in a second. Now, here is our draw scene function. The first thing we have right here is the ambient lighting. It turns out that that's hard to do, so what graphics artists do is they just add this little ambient light on. And the way we do it in OpenGL is we call GL light model FV with the first parameter as GL light model ambient and the second parameter as an array of GL floats. GL floats are kind of like floats, but what the compiler will do is it'll automatically convert these floats into GL floats. So our array right here, these first 3 parameters are the intensity of the ambient light, actually the color and the intensity. So we want a pretty weak ambient light, so we put 0.2. We're going to put 0.2, which is 20% lighting. And this 4th parameter is just 1. Just leave it at 1. And here's our first lighting source. We're adding a positioned lighting source, which is going to be at a particular position in our scene. So for this lighting source, we have to set up a couple of things. We have to set the color intensity by calling GL light FV. The first parameter is GL light 0 because we are setting it for light number 0. The second parameter is GL diffuse to tell it that we're setting the color. And the third parameter is light color 0, this array right here. And it gives you the intensity of the light, which is 0.5, 0.5, 0.5. And again, this 4th element is just 1. Then we have another call to GL light FV. And the first parameter is GL light 0 again. The second parameter is GL position because we want to tell OpenGL the position of our light. And the third one is this array right here, which is the position. These first 3 parameters are x, y, and z coordinates of the position, and they are relative to the current transformation. So we want to position the light at 4, 0, 8 relative to the current transformation. And this last one will just have 1. Then we want to add directed light to our scene, which shines in one particular direction across the whole scene, the same amount. So, again, we have 2 calls to GL light FV. We have the color intensity right here, which this time we'll use 0.5, 0.2, 0.2, which makes it sort of a reddish light, because there's more red component. And again, this last one is just 1. And then we set the position of the light. We need to tell OpenGL what direction it's coming from. So, same idea. GL light FV, GL light 1 for light number 1, GL position for the position, and then the third parameter is this array right here. We want the light to come from the direction -1, 0.5, 0.5. So mostly from the negative x direction, and also a little bit up and a little bit in, away, out of the screen. And this fourth parameter right here, we put 0 to indicate that it's a directed source rather than a positioned source. Right here we had 1, it's positioned. Here it's 0 because it's a directed light source. And down here we actually draw the 4 faces of a box that we're going to show. And for each box we need a call to GL normal 3F, which what that is it tells OpenGL the normal of the face that we're going to draw. What the normal is it's a vector that is perpendicular to the face. And we need to let OpenGL know what this is because, for instance, if the normal is almost opposite to the direction of the light, then we want the face to be lit a lot because the light is shining directly on it. But if the light is coming in almost almost parallel to the face, then we all want almost no light to come from, or we want the face not to be lit very much from that lighting source. So that's why we need to tell OpenGL the normal of each face when we're using lighting. And this call up here that I pointed out to GL to make things a little bit faster. But for now, we'll just leave it at that. And we have our 4 faces, front, right, back, and left. And each one has a call to GL normal 3F right before the 4 vertices, indicating the normal to that face. And by the way, these normals have to point outward, which they have to point outward because the back of the face we don't want to get lit because we're usually dealing with closed surfaces. So the back of the face just won't get any lighting because it'll all be absorbed by the faces in front of it. So that's why we need to make sure that this normal points outward. And let's see how it looks now. So compile the project and run it. And here we have it. We have our red light source, which is coming mostly from the left, but a little bit in, a little bit out of the screen, and a little bit up. And we have our white light source, which comes from the right and above. And this is how our box is lit. And there's one other concept I'd like to tell you about. Notice it has a jagged outline because it's actually, the polygons aren't very many. And how does this work? Well, what we do is at each of the vertices, instead of the normal to the face, we use the normal of the actual sphere that we're trying to approximate. And then anywhere on this face, say somewhere in the middle, it'll just average those normals together to find a different normal that it'll use for shading that particular point. So that's how we get this to look nice and smooth. And it's much better than adding lots of extra polygons because it takes hardly any extra time to render this compared to this, actually, which is pretty cool. So now let's see this in action. let's say our box is supposed to approximate a circle, which is kind of stupid. I mean, a square isn't a very good approximation of a circle, unless you're drunk or something, but whatever, we'll just see what we can do. So what it does is it makes it so that we specify the normal for each vertex, not just for each face. And we specify it right before calling GL vertex 3f. So these normals are the real normals that we would expect on the circle that it's approximating. And one other thing we have to do is we have to go back up to the init rendering function and uncomment this out so that we have the shading smooth by changing the shade model to GL smooth. Before we had it on, or we may have had it on GL flat before, which is just flat shading, not smooth shading. So if we wanted to change it back, we could call GL shade model GL flat. That's the basics of how we do lighting in OpenGL.